Welcome back to the series Java Collection Framework. So we've had two sessions so far. In the first one, we discussed about what is Java Collections Framework, how is it needed for programming, what are the uses of using a collection in your program, why do you need it, etc. All the basic details of why actually collection exists, right? Now in the second session that we had yesterday, we talked about the very first collection that we have, that is list. So in list we talked about array list and linked list, right? Now in today's session we'll quickly do a recap of all that we have seen so far and then move on to another two implementations of list, that is stack and vector. Now vector wasn't initially part of the collections framework. It is actually a legacy class that has been moved down to collection framework because it works as similar to collection framework. So before collection frameworks came into place in Java, vector was used as a formation of a mix of all the list, array list kind. So once collection framework came into place, vector was also moved into collection framework. And stack is extended from vector to provide us with the capability of a stack-like structure. So we'll talk about all that in detail in the session, but before that there were a few of you again yesterday who asked me where do we watch the archive of the live sessions. Okay, so I quickly take you to the YouTube and Facebook pages both to tell you how you can subscribe to the channel so that you can get notifications and where to go to watch the old archives. All right, so back to the screen. As you see, this is the YouTube page. All you have to do for going to the channel is in the search bar after YouTube, just say IT careers. All right, and you'll land on the TalentSprint IT page, that is TalentSprint IT jobs and placement. So just subscribe, click on this button to get all the notifications for upcoming live sessions or notification whenever a new video is uploaded. And to check the previous videos, click on the videos and you see all the videos that have been uploaded so far. So this was the first session that we had, introduction to Java collections, and the second session we had array list and linked list. All right, same for Facebook. Just go ahead and in the search bar after the Facebook type /TalentSprint. You land on the page, go to the videos. In the left bar you'll see videos as the fourth tab. Click on it and you'll get to see all the previous videos. So part 1 of 7, part 2 of 7, and this one is the live that's going on right now. Okay, so that is how you can go back to check in detail what we have discussed so far, for those of you who have joined new or for those of you who want to recap all the previous sessions, right? And before I start off the session, let me check who all have joined us so far. On Facebook we have Krishna, Sheikh, Purushottam, Nagesh. Hi everyone. And on YouTube, okay, I'm looking this side because my system is right here where YouTube chat is open. So on YouTube we have Madhav Rapu, we have Raj, Saurabh, Karan. Everyone has already joined. Raj says, ma'am, we need examples of collection based programs. Raj, we have example, I have added an example for you today for vector, so we'll take a look at that. And Savan, hi Savan. मैम क्या आप मेरे जीडीपी में प्रोजेक्ट बनाने में मदद कर सकते हो? मैं अभी 12th क्लास में हूँ और आर्ट्स ले रखी है. सावन, I have no clue about arts. I am from PCM background. I had PCM in 12th, so I really cannot help you with a GDP project. But I'm sure if you do a Google search, check out all the channels that are available, you will find a lot of help out there on the internet. There's everything available on internet these days. Then Madhav Rapu says, ma'am, could you please explain me difference between static variable and static void? Madhav, there is a class on static only, one of the class dedicated to static keyword only, and you can go back to the YouTube channel, check the previous live classes, and you'll get a very detailed explanation of the difference between static variable, static method, static block of code, static everything, whatever static possible, everything was discussed in the live class. So I'll suggest you go back to the channel and quickly go through that session to brush it up nicely. Hi Ajay. Hi Tanmay. Tanmay says Java sucks. Okay, if you hate it so much, I'm really sorry about that, but it is not that bad. If you quickly, slowly start getting on the track with practicing, you will really find that it is interesting at very many levels. Dharmendra, Praveen, Amit, hi, hello everyone, Prachi, Mohit, Kiran, Akshay. Akshay says, can you provide an example on stacks? Okay, Akshay, we will get to the session now, and step by step let's look at examples as well as implementations of both stack and vector. So I'll switch to the screen now. If you have any doubts at any point, just drop a comment. So we had a detailed discussion in the first session about collection framework, java.util.collection class that has all these methods, and all the methods are public abstract. Now java.util.collection is an interface. All right. Moving on to collections, that is different from collection. Remember, collection class is the root class of collection, and collections is a utility class that provides static functions to perform operations on object of collection, and these are all the static functions provided. Okay. Further, next we also checked difference between synchronized and concurrent collection. Okay, so for the matter of thread safety, we have synchronized and concurrent collection. Now in short, if I have to say again, if we have a collection, let's say if we have a map, if you used synchronized map, whole map will be accessible by one thread at a time. But if you have a map again, let's say this big, and you are using a concurrent map this time, okay, so the segment of map will be accessible by one thread, and other segment is available for another thread to be accessible. Similarly, if there's one more segment, as many segments are there, as many threads can access a concurrent collection simultaneously. All right, moving on, we discussed list provide us with positional access. We have a lot of discussion around search, iteration and range view for list. We saw the methods add, get, index of, last index of, remove and sublist if you want to create a sublist of an existing list, right? Further, we saw how to create array list, we saw how to create linked list, and we also discussed what are the differences between both array list and linked list. All right, and we also quickly took a look at doubly linked list that provide pointer for both previous node and the next node. Okay, now moving on to vector. So what is a vector? As I said, vector is a legacy class that has been brought down to the collections framework. Now vector, as it is part of a list, again it maintains its insertion order. So whatever order you insert your objects in a vector, they will remain in the same order, right? The difference between a vector and an array list essentially is that a vector is synchronized while an array list is not synchronized. Okay, so that is the prime difference between vector and array list. So when you're using a vector, you might encounter poor performance in search, add, delete, update. So until and unless synchronization is a primary condition in your program, it is advisable to go for array list and not for a vector. Now another difference is that when you use an array list, let's say you have the default size for an array list is 10, right? So when you increase the array list, let's say when you insert the 11th element in the array list, the size grows by half. Okay, so if the size was 10 previously, the size will become 15. While in vector, it is slightly different. So when you create a vector using any of these constructors, which we'll discuss in about a minute, when you create a vector, but the default capacity, the default initial capacity of a vector is 10. So if you create a blank vector using this empty constructor, the vector vec would have capacity 10. All right, now as soon as you add the 11th element in the vector, like it's a collection, it will expand in size, right? It will not block you from adding 11th element. As soon as you try to add the 11th element, vector size increases by double. So the size becomes 20. It doubles itself. So when you increase the 21st element, it again will double itself. So the size would become 40 now. While in array list, it is increasing by half. Alright, that is one of the difference between vector and an array list. Cool. Now moving on, let's see another implementation. So this is the first implementation where we are using a blank constructor to create a vector. Another option that we have is where we provide the initial capacity. So we can say that we want a vector of size 15, and this will create a vector of size 15. Another variation is you say that a vector needs to be created from the current collection. So let's say you want to convert your array list into a vector because you want a synchronized form of array list. So first you created, let's say, an array list. All right. Now this array list you want to convert to the vector. So all you have to do is say vector and provide this collection inside as a parameter. This will create a new vector for you with all the elements of the array list inserted in it. Okay, and the final variation is this, where you see a vector is created. We have initial capacity like we had right here, and we also have capacity increment. All right, we saw that by default the size of a vector is 10, and it increases by doubling itself every time it bounces off the size. Okay, now if you don't want the size to be increased by 10, you want a particular capacity, you can specifically say that. Let's say we create a, let me just change the color. Let's say we create a vector saying that the initial capacity is 4 and the increment size is 6. Okay, so till you have 4 elements in the vector, the capacity will be 4. As soon as you add the 5th element, the capacity will become 4, that is the initial capacity, plus capacity increment, this value, that is 6. So as soon as you enter the 5th element, the capacity of the vector becomes 10. Similarly, when all 10 elements are added, if you try to add the 11th element, right, the capacity would become 10, that was the initial capacity, plus again increment capacity, that is 6. So now the size would become 16. All right, that is how this variation of vector construction works. All right, cool. Now let me go further to the functions. So before I jump onto the functions, I'll quickly take a look at the chat if you guys have any doubts related to the question so far. Rajat said, ma'am, could you please explain tree set? Rajat, the set will be covered in the class that we are going to have on Monday. So Saturday, Sunday, there is no class. We'll continue on Monday, and on Monday's session, we'll discuss about set. So anything related to set will be covered in that session. All right. Pawan says, could you please explain before learning advanced Java what need to learn? If before learning advanced Java, all you need to know is to understand the basic syntax of Java, that is simple for loops and while loops, if conditions, basic operators, etc. You should be able to write a normal program in Java before moving on to advanced Java. Nothing else is a very huge requirement for moving on to advanced Java. All right. Ashish is asking, what is the use of stack in real lifetime? So stacks are basically used in real lifetime when you deal with mostly Excels. So you want the data to be popped in and popped out in accordance with how the data is provided in the Excel. So you don't want to delete from the middle, you don't want the first element to be deleted, you just want to operate on the last element that has been popped into the stack. In those scenarios, you deal with stacks. All right. SS Reddy says hi. Prachi says, nowadays Java where is used? Prachi, there are so many systems and softwares and websites, apps, Android apps out there which are developed, which have been developed and are still being developed on Java. Plus Java is a very good starting point if you want to get into JavaScript or Android development, etc., etc., website making. Many things still are using Java. So Java is a very good start off point if you are getting into coding. Okay, can you make a session on serialization and deserialization? All right, noted. Kiran says, can you override a private or static method in Java? Again, Kiran, I'm not taking any other questions other than the session that we are discussing. This again we have taken up in a live session before, so I would suggest go back to the live session and take a look at the questions. You'll also get the questions which have been in detail solved, and we have discussed all private, static, everything in there. Saurabh says, example of stack is library where books are kept in stack method, means last in first out ways. If you want to pick one book, then the book which is kept in the last in the column is picked first. Okay, Saurabh, I think you try to, instead of a shelf, if you say a pile of books, I would say this is a decent example, but if it is a shelf of books, I can take a book out from anywhere. So not a very specific example, I would say, when you're talking about stack. Dharmendra says, by default, which collection is synchronized and which is concurrent? Okay, by default you can get synchronized as well as concurrent collection depending on the package that you use, that is the class that you use. So if you use java.util.concurrent, that we'll talk about in one of the later sessions, you can get everything. You can get a concurrent set, you can get a concurrent map, but depending on the class that you use. If you use just the collection class, in collection class by default everything is synchronized, if at all it is thread safe. Like vector is a synchronized class. All right. Kiran says, what is the difference between fail fast and fail safe iterators? Kiran, iterators are going to be discussed in the last session of this series, that is day 7. So fail fast and fail safe both will be discussed on day 7 in this series. Okay, stay tuned for that. Okay, stack using last in first out and queue using first in first out, that is true, Saurabh. Amit says, we can make synchronized version of array list, then what is the use of vector? That is very correct. So vectors are not officially like used, it is not suggested to use vectors because they give very poor performance. It's just that it is part of our legacy systems before Java collections came in, and these sort of questions related to vectors are generally asked in your interviews or written examinations to check your understanding whether you know that vectors are part of array list or part of essentially list or not. All right, but otherwise they are not used much in actual coding or programming interfaces. Ma'am, can you explain second constructor of vector? Okay, second constructor of vector was the vector that says initial capacity. So whatever capacity you want your vector to be. See, if you use the default capacity is 10. So the size of your vector is 10 if you use it. If you don't use that, if you use the second constructor, you can specify whatever default size. So if you know your data set is going to be greater than 10, it's going to be around 50 or around 100. So you can specify that capacity right here when you create the vector, and it will accordingly create your vector of that size for you. Okay. Dharmendra says vector is not clear to me. Dharmendra, vector is nothing but an array list that is synchronized. That is the whole difference between vector and array list. And another simple point is that the size increment in array list, if you go beyond the size, the size increases by half. But in vector, if you go beyond the size goes double. Those are the two differences. So vector is by default synchronized, array list is not. But you can, as said by, rightly pointed by someone, you can synchronize array list as well and use it in your program. All right. Rohit is asking, no class tomorrow. Rohit, sorry, there's no class tomorrow. I want you guys to enjoy your weekend. So we'll meet with the next session that is set on Monday. All right. Why java.util.stack is implemented using vector and not array list? Because it's easier to implement it using vector, like it uses some of the initial properties and functions of the vector class, and then it adds on 5 methods of its own to implement that stack functionality, which we'll take a look at a little later. Narendra, I hope I answered your question. The need to discuss is that this kind of question around vectors are generally asked in written exams and interviews to know that if you are aware of the whole framework or not. All right. Ali says, I'm new here and I want to know about this. Ali, welcome to the session. I hope you are enjoying it so far. And this is Java Collection Framework series. All right, so that is it. I'll quickly move on to the next slide that shows you the functions of a vector. Okay, so we have add element, which is simply used to add an element to the vector. We have capacity, which gives you how much a vector can hold. So if the capacity of the vector is 10, that means 10 elements can go inside that vector, right? And what size means is how many places are actually occupied with data. So if out of 10 only 6 elements are present in the vector, 4 are empty, so the size would give you the actual elements present in the vector. Contains check whether a particular element is present in a vector or not. Element at will give you the element at a particular index. So if you want element at index 5, just mention 5 here, it will give you whatever element is present at the index 5. Remove element removes the particular object. Remove all will remove the collection that you provided, and is empty will check whether the collection is empty or not. So will return true or false. It returns a boolean value, true or false, depending on whether your vector is empty or not. Okay, so moving on to the program, we have a small program right here. I want you all to go through the program, and there are system.out.println statements in this program. So go through the program and be ready with the output for the print statements. What will each of these print? All right, I'll give you a minute to go through. Meanwhile, I'll just go through the chat. Pawan is asking difference between system.println and system.print. System.print, Pawan, prints it in the same line. It doesn't add the end of line or the next line at the end of the line. While println will print your output, whatever there is, and will move the next output to the next line. So if you don't want to confuse yourself with multiple print statements printing in one single line, you use println. Indra has just joined. Hi Indra. Sundar is asking anything about BIPM stream. Sundar, we are not going to take up anything about BIPM stream in this session. So on the screen, as you see, we have a simple program. We have imported the vector class, and in the main method created a vector. Now the vector is a string vector, so we have a specialized vector, added 3 elements, first, second and third, to the vector, and then there are a few println statements. All right. And I've already started receiving your outputs. Ubaid is asking, I am a fresher and I wanted to know which topics of Java should I prepare to crack an interview. Ubaid, the very basic object-oriented programming concepts, all polymorphism, inheritance. Of course, if you are preparing Java, OOPS concept should be very, very clear. And apart from that, the simple syntax of conditional statements, looping statements, operators, the basics of Java should be well brushed. That is the bare, like minimal what you can prepare for cracking an interview. Of course, you can add on top of that whatever you want and whatever you have time for, but OOPS concepts and the basic conditional iterational constructs. Okay, Chaitanya has answered first, second, third, right? So the first will print out first, second, third, and the output would come out something like this. Since it's a vector, it will start off with a brace, first, second, and third. Now you might have a question which gives you certain outputs which say first, second, and third, but the braces are missing in one of the options. So the one that is right is with these square braces and first, second, third inside it, right? Now what is happening in this particular line is you are adding an element that is random, but you're not letting it add at whatever position is available. You want to add it at index 2, right? So at index 2, how will it go? This is index 0, this is at index 1, and right now third is at index 2. Now if you say that you want random to be added at index 2, random would be coming here, and whatever elements are behind this index would automatically shift to the next places. So third will come at index 3. This will be your new vector. First, second, random, and third. All right. Now when you say print vector, this is what you get as output. Again, when you check element at index 3 and you do a get function on the vector, the third element, the element that is at index 3 would come, that is third. Fine. In the next statement, we are saying the first element of this vector is, and we are using the method first element. So this gives you the first element of the vector. So this output will be first. The last element, again we have all these functions are predefined. That is the beauty of using a collection, that you already have predefined functions to do a majority of operations that you would want to perform on any such collection list. So if you want last element, you don't have to write a big tedious for loop to traverse through the whole list and then finally reach the end of the list to get the last element, right? Or if you're smart, you'll write a for loop that traverses the list from backward, but still it's tedious to write a for loop. Now here all you have to do is call a predefined method, that is last element, and you get the last element, that is third. All right. Now the last line is using, I'm not sure if you are able to clearly see this, it's using isEmpty method on the vector. All right, which will result into false since there are 4 elements present in our vector. Okay. Dharmendra is asking, so we have to delete first if we want to overwrite some element. If you want to overwrite some element, yes, of course you will have to delete it, or else it will happen what just happened here. You want to insert an element at position 2, it inserted an element at position 2 without deleting anything. You want to explicitly delete something or overwrite something, which means you want to delete the element and then write something. You have to explicitly do that. SS Reddy is asking why performance of vector is poor compared to array list. The performance of vector is poor compared to an array list simply for the reason that it is a synchronized element. It's a synchronized collection. So if you have one thread which is accessing your vector at any point of time, there is no other thread that would be able to access it. So if there are 4 or 5 threads waiting in line to access the same vector, they have to wait in queue for their turn, right? Till it releases the lock on your vector, other things cannot access it. So for that reason, the speed becomes slow, the performance of the program becomes slow, whereas array list is not synchronized. So if there are 4 threads who want to access the data of your array list, they can simultaneously check what data is at what place and then perform operations faster. So that is the simple reason why vector performance is poor compared to an array list. All right. Now moving on to stack. Okay, stack in itself is a very nice topic because there are a few details that you are expected to know when you're talking about a stack. Okay, so starting off with, I'm pretty sure you would have seen this diagram that I'm going to draw whenever you have heard about stacks, right? So what happens is, in a stack implementation, it is part of the list interface, but it operates slightly differently. Okay, first point is it has LIFO structure, that is last in first out, right? So whatever element goes last in the structure is the first one to get out of the structure. You cannot touch any other data apart from the last element that is inserted into the stack. All right. Now there is one more thing that you have to remember. A stack has a variable top that always points to the topmost element of the stack. Now if your stack is empty, top would be pointing to this place, that is the place before the first element. Cool. Now there are, like I said, 5 simple functions that are part of stack which make this implementation like we are going to see. So the very first is push. Anytime you want to insert any element into a stack, you have to call this function. So let's say we want to add 15. We say stack.push, whatever the name of the stack is, stack.push 15. If you want to add next 20, next 30. And by this time the top would point to the topmost element in the stack, that is 30, right? Now if you want to check what is the value of the topmost element that you have pushed on your stack, correct, the function that we use for that is peek. So this will not delete the data, this will not remove it from your stack, this will just give you the value of top. All right. Next, what we have is, if you want to delete the element, we have pop, and this will work again only on the topmost element. So if you say, if you declared a stack that is, let's say dummy, and you call dummy.pop, right, this will delete this topmost element, that is 30, and the top will now point to 20. Okay, so the pointing of top keeps changing based on what data are you adding or deleting. The topmost at any point is pointed by the top. And one more thing to note is that the index, if you want to go by the index, is checked by this. whatever the topmost element is, it is always at index 1, and from there on, how many ever elements are there at the bottom, keep adding one more index, like you do in arrays, right? But they start from 0. Here, whatever element is at the top, the index is 1 for that topmost element, right? Now moving on, next function that we have is, if you want to perform a search, if you want to check if any particular object is present in your stack or not, you simply call search on that particular object. Okay, and this will give you the value, the index where your element is found. So let's say if you want to find, this is our dummy stack, let's say if you want to find if dummy has the element 15 or not, right? If you call this dummy dot search 15, it will give us output 2 as it is found at index 2. All right, so these are the simple functions: push, peek, pop, search, and one more that we have is empty, that will check whether the stack is empty or not, right? So these are the 5 additional functions that are added onto your vector to make its implementation like this, the stack implementation that we say. These 5 functions help us achieve this implementation, that whenever an element is added on your stack, it is push. Whenever an element is removed from the stack, it is pop. And the other 3 functions that are peek, search, and empty, they are used to check what kind of data is there in the stack that we have at hand. All right. Okay, so this is a simple implementation. We have created a stack using a simple constructor, blank constructor, pushed 3 elements 15, 21, 33 into it, and we are searching for the element 21. What will be the output of this line? What is the value of index? Can't we delete element from middle of the stack? Dharmendra is asking. Dharmendra, pop works like that. That is why we use stack. Whenever you don't want any element to be deleted from the middle in your data set, you will use a stack. It will not allow you to delete middle of the stack. Of course you can, if you take out the data, store it somewhere else, meanwhile delete the topmost element that is your middle, and then put all that data back. But all that will, hinder the performance of the stack, because they are essentially used for this purpose, that you are not able to manipulate the data that is already present there. Can we make a vector concurrent? Dharmendra, vectors, if you want concurrent implementation, you will use array list. Why would you want to make vector concurrent? You clearly have 2 options. Array lists are concurrent and vector is synchronized. So many of you are saying the answer is 2. Rajat says 1. All right, cool. So what happens is, again, if you're not able to figure out looking at the code like this, simply keep putting the data in the stack. So when you say push 15, first element goes in the stack, that is 15. Next line, second element goes in the stack, that is 21. And finally, last element goes in the stack, that is 33. Now top points to this. This is index 1, this is index 2, this is index 3. Fairly simple, right? Now if you search for 21, you get 2 as output. Okay, so if at any point of time, this was, I think, fairly simple because we have done only push operations. Had there been a pop and more push and a series of operations like 10-15 lines of code, it's easier to do it this way. Just create your structure, keep adding, deleting elements based on the lines that are executed, and then go ahead and check whatever element you are searching for is at a particular point of time at what index. All right. So that was about today's session, guys. I hope you understood the concept of vector and stack, and with that we have closed off list interface. Now I'll repeat it again. We have the root interface, that is the collection interface. Under that we have the list interface, which gives us list form of implementations to use for our data to be stored. And in list we have 4 different variations. We have array list, we have linked list, we have vector and stack. And all these 4 implementations provide us with different parameters and variations to store our data in a way that we would want to. Like, all these are ordered, so whatever form you insert your data in is the form you will get your data out in. Both array list, linked list, vector, stack, everything is ordered, right? Then we have, like we saw in the first session, these are differentiated based on whether they are synchronized or not synchronized, or whether they are thread safe or not thread safe, right? So all these variations, now that you know, you can choose in your program based on the requirement of the program, based on the requirement of the data, which particular data set you would want to choose from, right? So that was it for today's session, guys. I'll see you with another topic from collection on Monday at again 7 p.m. So don't forget to join me. We'll talk about sets, different form of sets, and yeah, have a nice weekend and don't forget, keep coding. Bye bye.